In this tutorial we're going to look at atom economy calculations. The atom economy of a chemical reaction is a measure of the proportion of reactants which become useful product. Inefficient, wasteful processes have low atom economies. Efficient, cost-effective processes have high atom economies. To calculate the percentage atom economy for a reaction, we need to determine the mass of the desired product and divide this by the total mass of all the reactants added together. We then multiply by 100 to convert this fraction into a percentage. Let's look at an example. Sodium chlorate, which is NaOCl, is used in the manufacture of bleach. Use the overall equation below to calculate the atom economy for the production of sodium chlorate. The important thing to remember about atom economy calculations is that all you need to do the calculation is a balanced equation. Here we have two sodium hydroxides reacting with chlorine to give sodium chloride, water, and the desired product, the sodium chlorate. Once we have a balanced equation, the next thing to do is to look at the mole ratio and use this mole ratio as a number of moles of each reactant and each product. So in this example, we have 2 moles of sodium hydroxide, 1 mole of chlorine for the reactants, and for the products we have 1 mole of sodium chloride, 1 mole of water and 1 mole of sodium chlorate. The next step is to work out the mass of each reactant and each product in that balanced equation. To do this, we need the number of moles of each reactant and product, which we just determined, and the MR of each reactant and product. So now we can see the MRs that we've calculated. Remember, MR is only one of any of the reactants or products. So multiplying the moles by the MR gives us a mass for the sodium hydroxide of 80.0, for the chlorine of 71.0, sodium chloride 58.5, water 18.0 and sodium chlorate 74.5. At this point, we should do a quick check and total up the mass of all the reactants and check it's equal to the mass of all the products. If the masses are not equal, then we know we've made an error in our calculation. Here we can see that the total mass of reactants equals the total mass of products at 151.0. We can now use the equation at the top of the page to work out our atom economy. So we take the mass of our desired product, which, if you remember, is our sodium chlorate. So this has a mass then here of 74.5, and we can divide that by the total mass of our reactants, 151.0, and then multiply by 100. This gives us a percentage atom economy of 49.3%. Then check what precision you should be giving your answer to. The data we have been using here is MR data, which is all to a minimum of 3 significant figures. Therefore, our answer should also be given to 3 significant figures. For this particular reaction, 49.3% is the amount or proportion of the reactants which have been converted into useful products. Therefore, the remaining 50.7% is therefore waste. Let's try a second example. Here, sulfuric acid reacts with sodium hydroxide in a neutralisation reaction to form sodium sulfate and water. This is a much more familiar process than the previous one, so you would be expected to write the balanced equation yourself. So write the balanced equation for the process and then calculate the atom economy for the formation of the sodium sulfate. So we have sulfuric acid, H2SO4, reacting with sodium hydroxide, NaOH, to form sodium sulfate, Na2SO4, and water, H2O. At the moment, this equation is not balanced, so start with the metals. We've got 1 sodium on the left, 2 on the right, so we need 2 NaOH. To balance the hydrogen and oxygen, we then also need 2 water molecules. The next step is to look at the mole ratio to decide how many moles of each reactant and product we have. For this equation, we have 1 mole of sulfuric acid, 2 moles of sodium hydroxide, 1 mole of sodium sulfate, and 2 moles of water. The next step is to work out the MR of each reactant and product, and then use the MR in the moles to work out the mass of each. Using the MR and the number of moles, we can see that the mass of sulfuric acid comes out at 98.1 grams, the mass of sodium hydroxide at 80 grams, the sodium sulfate at 142.1 grams, and the water at 36.0 grams. At this point, we check our calculations are accurate by totalling up the reactants and the products and checking that these are equal. Both sides have a total mass of 178.1. So our next step is to actually calculate our atom economy, so using the equation at the top of the slide, mass of the desired product, here the sodium sulfate, divided by the total mass of the reactants, multiplied by 100. So we can see that this process has an atom economy of 79.8%. Again, giving our answer to 3 significant figures, since the lowest number of significant figures in the MR values is 3. So this is a more efficient process than the previous one. A greater proportion of the reactants are converted to useful product. Let's do one final example. So here we have magnesium metal combusting in an excess of oxygen to form magnesium oxide as the only product. Again, here you would be expected to write a balanced equation. So here we have Mg, magnesium, reacting with O2, oxygen, to give MgO, magnesium oxide. To get this equation to balance, we need 2 magnesium metal and 2 magnesium oxides. So for this equation, we have 2 moles of magnesium, 1 of oxygen, and 2 of MgO. Then calculate the MR or AR values, here in the case of magnesium. Using the MR and the number of moles, we can work out the mass of each reactant and the product, and then do the quick check, add up the total mass of reactants and the total mass of product. Finally, we can use our equation to work out the atom economy for the magnesium oxide, mass of the desired product over total mass of reactants times 100. In this case, there is only one product, therefore the total mass of the desired product over the total mass of reactants is 80.6 divided by 80.6, which therefore is 100% atom economy. Therefore nothing in this process is wasted. 100% of the reactants become the desired product. Watch for this kind of calculation in the exam. Any reaction where there's only a single product in the overall balanced equation will always have 100% atom economy, and therefore you can save yourself some time doing the calculation. Now have a go at the 2 practice examples. Pause the video as the answers will appear in about 20 seconds. Okay, check your answers to the 2 practice questions. Some hints are provided in the mass of desired product over the total mass in the equation. Okay, key things to remember then about atom economy. The first one is that all you need is a balanced equation. Any other data that you're given you can ignore. The second is that if there's a single product, then the atom economy will always be 100%, so you can save yourself some time and don't have to do the calculation. We hope you found the tutorial helpful. Go back, redo the atom economy calculations in your notes, and have another look at the homework questions.